way that I've chosen to attack this is to look carefully at, in tremendous detail, exactly where our planet is getting warmer. You can often see figures that look like this one, where we take observations of temperature from different stations. We have many different stations all around the world, and one of the things that's really nice is that with these wonderful night lights of the world, we can even tell where the pitch black stations are, the ones that have absolutely no urban influence, and we can just concentrate on those perhaps in generating a plot like this, or we can use all of them. They're all carefully corrected, and it doesn't actually matter which of those two things we do. And if we do that, we can have a look at how our planet has warmed. So the pattern here is clearly that the planet has gotten warmer relative to the period from 1950 to 1980, but yet it's not homogeneous. We see more warming in the Arctic, we see less warming at low latitudes, we even see some places that haven't warmed enough. I'm going to now show you a movie. Keep your eye on what's happening as we go through the years of our planet's climate history in the instrumental record. You can notice, for example, the El Niños that occasionally happen. They'll be manifested by the warming off the ocean just off South America. You'll notice it getting warmer in the Arctic, and by the time you get to the end, you'll notice the Arctic getting very, very hot. So if you ask yourself, where in the world will the local signal of human-induced warming become obvious the soonest? You might imagine that the place where that would actually be the Arctic, since it's gotten warmer, much warmer than the rest. I was very surprised by this research, which is one of the reasons I wanted to talk to you about it tonight. I'm always amazed by times when my research gives me exactly the opposite from the answer that I expected. And in this case, what I found was that the place where the human-induced local warming is the most obvious, earliest, is actually in the deep tropics, particularly the maritime deep tropics, as long as you're away from that El Niño region, which is so variable. So what you can do is have a look at models and observations. The observations are on your right. The 23 global climate models are on your left, the average of those. And I'm looking now at every grid point on this planet. They're roughly 2 by 2 degrees, something like that, so quite small. And this is showing you the variability from one year to another in the summer temperatures. So summers are actually quite variable in the northern hemisphere in particular, both in the models and in our 110 or so years of observations. If I look at the variability, though, the variability is lowest in the deep tropics. As long as you're away from the El Niño region, it's less than a few tenths of a degree. Our planet has warmed by about 0.7 degrees Celsius over that 130 years. So if the variability is a couple tenths of a degree in the deep tropics and much more at higher latitudes, what you'll find is that the highest signal to noise, the highest warming relative to the noise of interannual variability, will be in tropical Africa, the tropical Americas, tropical Asia. So the question is, can those regions adapt? It's really those maritime, deep tropical regions where the changes are the greatest already. We can look at this a little bit more clearly by looking at time series at different locations, and I find it really quite amazing that the summers in, say, the middle of Africa are already different. Every summer now is a measure that we can look at. We can look at the distribution of those summers, and you can see that what we're already seeing in those regions is significantly different from what it was before. If we look, say, in Russia, that isn't true. In America, it's not true either. So the question becomes, what are the effects on crops in these regions? What about forests? What about people, ecosystems, economies? We're producing in America about 10 times more carbon, 10 times more per person per year than the people in Colombia, 400 times more per person per year than the people in the Democratic Republic of the Congo. And yet they're on the front lines of global warming. Thank you.
Thank you. So while we've got somebody coming here, but just briefly, is there a difference to make between measurability of effects and likely impacts? Does it follow that because we can measure the signal-to-noise ratio is clearest in the tropics, that the impacts will be greatest there or not?
That's something that people are continuing to work on right now. I think you can imagine that in a place with high variability that the system will have adapted to that level of variability. A place with very low variability, a large signal, it becomes much more difficult to adapt to, particularly for cold-blooded creatures, because they can't regulate their body temperature. So people are doing work on insects, on lizards, on things like that.
Right, thank you. Yes, over here, please.
The ballyhoo about climate change and the climate getting warmer has really not been addressed properly, and many people have come out and have been proven to be false. The sunspot cycle seems to have much more impact than human, and that is not spoken of. And the concept of the Middle Ages...
I'm looking for a question here.
Yeah, do you see the possibility that we can get beyond the falsehoods spread by the system about climate change?
Well, I would think that we already have, actually. I would hope that some of what I had to say was useful to you. You can look for alternative mechanisms. You can try to find other reasons what might have happened, but it's very, very hard to make the argument that the sun is what's responsible for our planet being warmer, because over the last 40 years, the sun hasn't gotten brighter, the cosmic rays haven't changed. It's so easy to say, well, could it be something else? That seems like a counterfactual that doesn't really hold up.
Okay. Another question here, please.
Yeah, so I'm trying to understand what you said. Is what you're saying kind of that the changes in the tropics are more statistically significant than the changes in the poles?
At the local level, that's exactly right. You can actually see it at single grid points of 2 by 2 degrees.
And why
Whereas at high latitudes, although you have a big signal, you have high variability.
And why is that?
Largely because of things like changes in the circulation pattern. You know that, for example, when you have a cold front come over Boston and it gets cold, it's getting warm over the Arctic, so it's the exchange of air between high and low latitudes makes us sporadically cold and makes a particular place up there sporadically hot. So that gives you just a tremendous amount of up and down. We had a very warm winter in Boston. This last one, the one before, was very cold. So it's very difficult to locally see the change in Boston. It's much easier to see it right now if you live in the tropical areas in the maritime parts.
A question here.
How long do you think it will be until it's obvious that the change is happening here in these areas, in the United States, and do you think by then it'll be too late to do anything about it?
Yeah. On average, of course, our summers are already warmer than they used to be. Our winters probably are too. If you go forward a few tens of years, you're going to begin to see the signal-to-noise emerging in more and more local places. And I think that's going to be a big factor in helping people to understand what's happening and to making decisions about whether or not to take action about it. Is it too late already? My answer to that would be, it's never too late. The planet will be different. We will be adapting to changes. We probably already have made some interesting adaptations. Perhaps a good example is that Europe has experienced quite a few very, very hot summers, a lot of heat waves. A fair number of deaths happened in 2003 when they had a very bad heat wave, but then, of course, they've begun to adapt to that and have begun doing the kinds of things that protect people against those sorts of heat waves.
And one more question here.
Since we only have limited historical data on the temperature, how do we know this isn't a cyclic pattern and the weather is going to revert to previous patterns?
Well, you're talking about the overall warming of the 20th century.
Yeah.
The amount by which the 20th century has warmed is extremely unusual in the paleoclimate record, so it's pretty hard to see an analogous time. It's not to say that it's absolutely impossible, but if it were occurring due to some other reason, you would imagine, for example, that you might have seen a shift in the circulation pattern in the ocean, and we don't see that. That's the kind of thing that has happened in the past in the paleo record when you've seen massive changes in temperature. So there's pretty good reason to believe that at least half of what we're seeing is due to human activity.
Thank you very much indeed. Thank you.